We're going to talk about quadratic equations in this video, and really for this entire section that we're studying, we want to really just be able to solve quadratic equations in one variable, and we are going to see some in context, so that means word problems, and we're going to utilize two different methods to solve these quadratic equations. The book does use another one, but we are going to omit that one. So we're going to use factoring, we're going to use a quadratic formula, and then the one that we omit is completing the square. And if you're interested in that, please look at either the ebook or the physical book for that information. And then we're going to use this information to solve applied problems that are experiencing free fall motion or motion under gravity. Okay. So just so we're all clear on what a quadratic equation is to begin with, it's defined as a second degree polynomial. So we've talked about polynomials before, and so degree is the highest, so we look at the different terms, remember, and then we say the degree of the polynomial is the highest degree, or the highest degree term of all the terms. And so what we're going to see is something that looks like this. So we're going to see a lot of A, B's, and C's, so make sure to pay attention to those, but it's going to appear as ax squared plus bx plus c. And so A can't be 0, but the other ones could be 0. Alright, so moving on to our first method of solving quadratic equations by factoring. The idea that we're going to use is kind of an old one that we may have seen before. We're just going to give it a nice name, and it's called the zero product property. The text calls it the zero factor property, same idea. And here's what it says. So if we have two things that are multiplied together and they're equal to 0, then one of them has to be 0, right? The only way we can produce 0 is if one of them is 0. Now, this supposition here is absolutely critical, okay? We can only ever do this if we have two things multiplied together equaling 0. If it equals 1, equals 2, not going to work. It has to equal 0, okay? Number one mistake that students make, okay? So, what we can do is, when we call m and n factors, so we're just going to look at each of these examples below and try and factor them. So I want you to pause the video and try to factor these as best as possible, and then I'm going to resume the video with a few pushes in the right direction or some factoring in some cases as well. So try these on your own and resume the video when you're ready. And so here is the factored forms of each of these, and we'll kind of go through these one by one, but in the first one, using the zero product property, I would set this first factor equal to 0, 2x minus 7 is equal to 0, and then solve this, so add 7 divided by 2, x is equal to 7 over 2. This next one, again, I would set this equal to 0, so 2x plus 7 is equal to 0, and then solving x is equal to minus 7 over 2. Okay, so here, and again, the instructions just say solve, so this is enough. Okay, so if it said solution set, write the solution set. Similarly here, I factor this one. Students on this one like to pull out an x first, x and x minus 4 is equal to 21, and then they misuse this property and they say, okay, well then x is 21, or x minus 4 is equal to 21, and then so x is equal to 25. Okay, and then again, if you were to check this, always check your answers, people. These are not going to work. Okay, zero product property has to have 0 on the other side, so then solving these you get x is 7 and minus 3. Okay, similarly here, you'd factor this one, pull out the GCF, ends up being a perfect square. X is going to equal minus 1. Here, factoring this one isn't completely obvious, so you might need to use the AC method. That is fine. You get q is equal to 1/2 from the first factor, and then 2 from the second factor. This fifth one here, kind of challenging to factor this one. You'd likely have to use the AC method. You could multiply by a common denominator to clear all of them. I left it as is because I recognize that this first one is m over 3 all squared. This one is 1/4 squared, and then this ends up being a perfect square. But then solving for m, so we'd get rid of the square root. We'd have m over 3 is equal to 1/4 multiplied by 3, so that gives us that m is 3/4. And then this last one, this is one that, again, students like to misuse, the zero product property, and they say, oh, okay, there's two factors already, equal to 2, set them equal to set them each independently equal to 2, not going to work. Again, has to equal 0. So then you actually have to do some, FOIL it out, and then subtract, and then do all this. You end up with y is 4 and 1. Okay, so we have the answers for each of these. Now, technically, the first one could be solved the second way. You wouldn't necessarily need a factor. You could just isolate the x term, or the term with the x, so 4x, move the 49 to the right-hand side. You get 49 over there, divide by 4, x squared is equal to 49 over 4, and then square root both sides. And whenever you introduce a square root, and I'll write this down in a minute, you have to include the plus and minus. Okay, so just a note here, you introduce, or intro, the square root, remember plus and minus. If the square root is there already, then you don't need to worry about it. Use the sign that's there. Okay, so this one, we got a lot of practice factoring, and we're going to end this video with doing a quiz. So take a shot at this, try solving it using factoring.